Hi, this is Dr. Xu teaching design of experiments for engineering research. We have talked about the comparison of two means and if the variance of the two products can be reasonably assumed to be the same. We use this equation to calculate the t-value, and in the equation we use the pooled sample standard deviation calculated by this equation. And the degree of freedom is the sum of the sample size minus 2. For example, in the chemical treated cement strength example, if we compare the spread of the data points for the two products, here and here, we can see that the range of the spread for the blue dots and the red dots are not substantially different. Further comparing the sample standard deviation, we can see that the two values do not differ too much. Therefore, we can reasonably assume the strength variance for the two materials are equal. Thus, we can use the method here to calculate the t-value and the degree of freedom. However, this may not be the case all the time. Let's look at one example. In medical surgeries, the nerve tissues and the muscle tissues are difficult to be clearly identified. We want to avoid cutting the nerves as much as possible, thus need a way to help the doctor easily identifying them from the muscle tissues. One fluorescently labeled product claims to bind to nerve tissues more than muscle tissues. If that is true, more level of fluorescence can help the doctor to easily identify the nerve tissues during surgery operation, thus avoid damaging them. So we would like to test the hypothesis that the mean fluorescence level for nerve tissue is greater than that for muscle tissue. We have formed the hypothesis test with the null hypothesis being the mean fluorescence levels for nerve and muscle are the same, and the alternative hypothesis is the mean fluorescence level for nerve tissue is greater than for muscle tissue. We will use the common significance level of 0.05 in the hypothesis testing. Experiments has been done using mice tissues. We have 12 observations for both the nerve and muscle tissues. From the dot plot here, we can clearly see that the spread for the red dot here is clearly larger than that of the blue dot here. Calculating the sample standard deviation, we can see that the nerve tissue fluorescence level sample standard deviation is more than twice of that of the muscle tissue. Thus, we cannot assume the population variance for the nerve and muscle tissue fluorescence levels are the same. So in the example, sigma 1 square does not equal to sigma 2 square. In this situation, we will not use the pooled sample standard deviation in the calculation of the t-value. Instead, we will use this equation to calculate the t-value. This statistic is not distributed exactly as a t-distribution, but it is well approximated by a t-distribution if we use this equation to calculate the degree of freedom. You can plug in the numbers and get the result of t being 2.7354 and the degree of freedom is 16.1955. Using the Excel function for the one-sided t-test, we use this function to calculate the p-value. So this parameter is 2.7354 and this is the degree of freedom, which is 16.1955. The returned p-value is 0.007, which is less than our predetermined significance level of 0.05. Thus, we reject the null hypothesis and conclude that there is strong evidence showing that the fluorescence level for nerve tissue is greater than that of the muscle tissue. We can also use the data analysis function in Excel worksheet to perform the hypothesis testing when the two variances are not equal. So in the Excel, I have copied the experimental data to here. Then we go to Data and click this Data Analysis. If you don't have this data analysis, you can go to File, Options, Add-ins, and select Excel Add-ins and go. And here, you just need to check this box here and click OK. Okay, now select Data Analysis. Scroll down here, we have the t-test, the two sample assuming unequal variances. Select it, OK. And variable 1 range, select here. Variable 2 range, select here. Hypothesized mean difference is 0. The significance level is 0.05. Click OK. The result is shown in a new workbook. Here we can see the mean of the two variable and the variance of the two variable and the calculated t-value, the degree of freedom. Because we are doing a one-tailed t-test, the p-value is calculated here. Alright, this is how we perform hypothesis testing when the two population variances are not equal. This is Dr. Xu. Thank you very much for watching. I will see you in the next video.